Welcome to the squeeze theorem. So the squeeze theorem states, so if f of x is somewhere between two other functions, let's say h of x and g of x, for all values of x, except for we're looking at a specific x coordinate, x equals c on the interval from a to b, and let's say that that h of x and g of x have the same limit. That means that the f of x, which is between them, is going to be squeezed in between my f of x and g, or my h of x and g of x. So for example, so here's my g of x. Right here is x squared, okay, in green. In blue is negative x squared. And so here is my blue function, here is my green function. And my f of x is x squared sine of 1 over x. Well, for all values of x, this red function is always going to be in between the blue and the green function. So if I'm looking for a limit that's just not calculable, let's say if I was trying to find the value of f of 0, I'm not going to be able to find that. So what I'll use is the squeeze theorem. So what will happen is g of x is creating an upper limit. H of x is creating a lower limit, and f of x is required to stay in between them. So what we can use is if the green and blue functions are approaching the same value, then the one in between is forced to go between them as well. So there are three special limits. The first one is going to be sine x. The limit is of x approaches 0 of sine x over x is equal to 1. The next one is going to be the limit as x approaches 0 of 1 minus cosine all over x. That's going to be equal to 0. And then finally, the limit as x approaches 0 of 1 plus x over 1 over x. That's actually how we get e, the 2.7 stuff. So let's look at several examples. All right, here's my first example. Go away. So the limit as x approaches 0 of tangent of x all over x. So if I was going to substitute in, tangent of 0 is 0. And then if I substitute in, again, of 0 over x, so I have 0 over 0, which is an indeterminate form. So that doesn't really tell me anything. So what I'm going to do is I'm going to split up my tangent. So tangent is considered sine of x over cosine of x. And I'm going to multiply that by 1 over x. All right, so in that case, I could rework or reorder that function. So one of my special squeeze limits is actually going to be sine of x over x. And so if I kind of reorder that, that means it becomes 1 over cosine of x. Well, this is kind of acting like the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of 1 over cosine of x. Well, if I substitute in, I know the limit of sine x over x as x approaches 0 is going to be 1. And if I substitute in 0 into cosine of x, then cosine of 0 is 1. So the limit as x approaches 0 of 1 over cosine of x is going to be 1. And so finally, this limit is actually going to be 1. Alrighty, so let's move down to number 2. So very similarly, you see that sine of 4x over x. Well, this is almost the correct form, except for I'm missing a value right there. What I'm missing is the value of 4. So if I substitute in, no, not what I want. If I substitute in a 4 here, that means I'm dividing by 4. I need to multiply by the reciprocal of 4. So I'm not really changing the problem. So really these two values really do cancel each other out. 4 over 4 do cancel each other out. However, what I'm doing is I'm changing. So I have 4 times the limit of sine of 4x over 4x as x approaches 0. And so this right here is going to have a limit of 1. So I have 4 times 1 is equal to 4. All right, moving on to number 3. So you'll see that in the numerator with sine, I have 5x, and in the denominator, I have 2x. So I need to multiply, since my denominator is 2x, I'm going to go ahead and substitute that out and move the 2 outside of the limit and have a 1/2. And I have, within that 5x, I need to multiply the bottom by 5. Well, if I multiply the bottom by 5, that means I need to multiply the top by 5 as well, so I don't change the problem. So what this becomes is I moved the 1/2 to the front. I have the limit as x approaches 0 of sine of 5x over the 5 that I multiplied before, and the x, so those guys will go to 1, and then I still have this 5 on top. So I'm going to go ahead and move that 5 over with the 1/2. So I have 5 over 1/2 of the limit as x approaches 0 of sine of 5x over 5x. Well, this right here, that value is going to be equal to 1. So I have 5/2 times 1 is equal to 5/2. So many of you probably figured out that there is a little bit of a trick, and that trick being whatever is with the x values, either the 5 with sine or in the denominator, the coefficients for those two values is going to be whatever the limit is. So let's come down to number 4. So again, in number 4, I see pieces very similar to the squeeze function earlier, except for I have this x squared. So what if I instead split them up so that I have the limit as x approaches 0 of sine x over x times 1 minus cosine x over x. Well, that means that's become the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 minus cosine x over x. And so if you look above, the limit as x approaches 0 of sine x over x, that's going to give you a value of 1. And then the other one, the limit as x approaches 0 of 1 minus cosine of x, that's actually going to give me a value of 0. So if I multiply this together, that means my answer is 0.